Being the queen bee may have its perks, but there's a lot of stress to the job. Sure, you have worker bees bringing you food, grooming you, and caring for your babies, but you're responsible for the livelihood of your children, not just 3 or 4 babies, but tens of thousands. That could put tremendous stress on anyone, queen bees included.
Welcome to the Bee Lab. My name is Mohamed Alburaki and I'm a research scientist. Basically in my lab we are focusing on queen health and performance. The queen is a very important member of the colony. She is the mother of all the bees. Taking care of the health of the queen is very essential for the overall well-being of the colony and the performance of the colony, whether it's in terms of brood production, disease resistance, as well as production of honey and the rest of the product that we get from the hive.
Here at the Honeybee Lab in Beltsville, Maryland, Alburaki focuses on the health of the queen bee, the ruler of the hive, the mother of all the children, and the lone member of the throne. It's all about her, the queen, and keeping her healthy and stress-free is paramount.
If the queen is not doing well, then the whole population will degrade gradually and the performance of the whole colony will drop. And then we'll have mortality and we'll have other issue will come with in terms of disease for the whole population. So when we study queens, we studied queens in light of the whole population.
Of course, the queen's health isn't just vital to her hive, but to beekeepers as well. There's over 100,000 beekeepers in the U.S. Some are backyard beekeepers who have a few hives and serve their local communities. Commercial beekeepers have hundreds, some thousands of hives. That's millions of bees. Their role in agriculture is essential as they deliver bees to fields all over the country. And those bees pollinate many of the foods we eat, like almonds, apples, and blueberries. Beekeepers also play another essential role. They're on the front lines of colony reductions.
In the US, one of the problems that we've been hearing from beekeepers is poor performance on the queen that we are producing in the US. To address this issue, it's a complex process because queen go through a complex process to become the mother of the hive and established queen in a colony. In my lab, we study different aspects of the maternal lineages of those queen.
Much of this boils down to genetics. Does the queen have good genes? Or perhaps more important, does the queen have a diverse genetic background?
If they are genetically susceptible to disease and stuff, no matter what you do throughout the process, they will still have to express their genetic ability to resist disease, to be adapted to the environment, and so on and so forth. And then you have the abiotic stressor that will affect the whole community. So it's a mix. You can't study just one single aspect and find a cure for a big question. So you need to put the puzzles together. And that's what we do in the whole bee research lab.
Alburaki is studying the genetic history and diversity of queen bees here in the U.S. He sampled queens from across the country, captured different DNA markers, and then tested them for genetic diversity. What he found was a low diversity among the queen's genetic makeup. Basically, what's happening here is beekeepers are breeding queens from their existing hives. This produces new queens who have genes similar to the predecessors. Alburaki calls this mediocre diversity, and he sees it as a major concern.
By requeening every year, we are recycling an already mediocre diversity. When we talk about queen, we talk the diversity about the whole bees because the mitochondrial DNA is passed through from the queen to the drones, to the bees, to the workers. Because usually when you see a problem with all the queens across the big nation like the US, then the question is not like a punctual problem here and there or in an area or not. You probably have to address a question on the genetic background first.
Queen bees should have a diverse genetic background for many reasons. It enables them to better fight off pathogens. It keeps them stronger and healthier. It allows them to adapt to different climate conditions, and these diverse traits are then passed on to their children.
For example, the susceptibility to disease, even in human being, is related to our genetic baggage and background. Some people are lactose resistant or not. This is due to our genes and how much they are diversified, and that's a general notion. More you have traits and genes that can deal with many stressor, more your body can respond and shield you from the abiotic and biotic stressor of the environment. This is the exact same principle whether it's on bees or on human being or any living organism. Now, since those bees were domesticated, they are no longer at what we call the Hardy-Weinberg equilibrium, where the weak will die and the strong will survive. This is a complete different context. The natural selection doesn't apply here. So we need to be careful about our own selection and what we are selecting, and especially that all the honeybees, they are not native of the US. They've been imported. So the question is how much we've imported from their native lands.
Diversity is especially important today, where beekeepers often move their bees around the country. That forces the bees to not only pollinate different plants and flowers, but adapt to varying climates throughout the year. For this reason, beekeepers should breed a subset of queens with genes that match both their living and working environments.
Basically, it's a natural selection. They are very well adapted to, because this is their homeland. Oh, I grew up here, I know all the area. I'm a local guy, But now we're living in a time of globalization. We are moving bees and then bringing them to a new environment. They may adapt, but they're not going to adapt in 10 years, 20 years, 50 years. They've been evolving millions of years, so the scale is very important here. What we can do is assign subspecies to climate zone, for example. In the US, we have 5 different climate zones. Some of them are dry, some of them are wet, some of them are cold. You can't bring an Italian bees from the Mediterranean and put that subspecies in, for example, Arizona, or in a harsh desertic environment. The probability of surviving or resisting the local stressors is much less than if we bring Syriaca, where their mainland is basically a desert area mainly. So this is a very critical point that is not applied here in the US currently.
What we'll learn in an upcoming episode is a growing trend for beekeepers to keep their bees in the same climate zones. Benefits include less travel, fewer temperature discrepancies, and familiar plants and flowers for foraging.
The major question is, do we treat them as a livestock, or do we do some program of preservation and local adaptation to the local climate? And that's a major question. It's not easy to answer this question or to even implement the proposal. But if we don't do that, we will continue having losses and then curing the symptoms, but not really the disease that we should address first.
Alburaki said he's hopeful that his research will encourage beekeepers and bee breeders to employ diversity in their craft. There are only 8 species of honeybees in the world, but there are approximately 32 subspecies, many of which have adapted well to certain climates. Breeding queens using diverse stock and subspecies will increase their diversity and help them face the myriad of challenges posed to them today.
We need to propose a sustainable strategy overall to better the life of the bees, and we need them for pollination, we need them for agriculture, we need them for beekeepers. The overall goal is to solve the problems that we are facing and to propose strategies to better the life of the bees and their health.
In our new episode next week, we'll get advice on how you can make your yard friendlier for honeybees and other pollinators.